Hello and welcome to the tutorial for GCSE Chemistry, topic C1, Atomic Structure in the Periodic Table. This tutorial will cover part 3, Atomic Structure. We'll be looking at the history of the atom and atomic structure. Remembering these keywords, an atom is the smallest particle of a substance, an element is made up of the same atoms, and a compound is when elements are joined together chemically. Starting off with the history of the atom. So what we know an atom looks like now hasn't always been the case, and the ideas of atomic structure have changed over time. In the early 19th century, John Dalton said atoms were solid spheres. In 1887, J.J. Thomson proposed the plum pudding model. He basically said atoms had negative electrons in it scattered around, a bit like a plum pudding. And overall, they had a positive charge, shown here. In 1909, Rutherford completed some experiments, and what he did is he fired some alpha particles at thin sheets of gold, so the gold atoms. He expected that the alpha particles would just go straight through, but they were actually reflected back in certain areas. So he realised that in an atom there must be something reflecting them back, and he came up with the idea that there was a nucleus at the centre of the atom. Later on, studies by scientists like Niels Bohr added that there are electrons in orbits or shells around the nucleus, and then further studies have confirmed that there's actually subparticles, electrons, neutrons and protons set up in the shells, which we've mentioned before. So you just need to have an idea of how the history of the atom structure has changed over time. Going back to atomic structure, so remember, atoms are made of electrons, protons and neutrons. The numbers that they have of each of those depend on what element the atom is from. Protons and neutrons are found in the nucleus of the atom, and electrons are found in the shells. Protons have a positive charge, electrons have a negative charge, and these two numbers in an atom are always the same, which means atoms have no overall charge. Neutrons are neutral and they're in the nucleus. When you look in the periodic table, each element has a different atomic number and mass number. The atomic number is the number of protons or electrons. The mass number is the number of protons and neutrons. You can use these numbers to figure out the number of protons, electrons and neutrons in an atom of different elements. Look at this example of sodium. It has 11 protons. It therefore has 11 electrons. It has 12 neutrons, and that is found by taking the mass number and taking away the atomic number. So 23 take 11. So let's look at electronic structure. How are the electrons in the shells or orbits arranged? Sometimes you can call them energy levels as well. Well, starting with the first shell, that can take 2 electrons. The second and third shell can take up to 8 electrons. And the rules are that you can only go on to the next shell when the previous shell has been filled up. Most atoms don't have a full outer shell, and it's that makes them react or bond. Apart from elements that are in group 0 of the periodic table, they have a full outer shell, so they don't bond. So let's look at an example of sodium. So we know that sodium has an atomic number of 11 and a mass number of 23. Those numbers are found in the periodic table. This tells us it's got 11 electrons. So how would we arrange those 11 electrons? Well, there would be 2 in the first shell, then 8 in the second shell, and then finally 1 in the outer shell, the total which makes 11. You would write this as 2, 8, 1. Here's an example of carbon. Carbon has 2 electrons in the first shell, then 4 electrons in the second shell. So you'd write this as 2, 4. Its atomic number is 6. It's a total of 2 and 4. So what are isotopes? Well, isotopes are different versions of the same element, and they don't appear in the periodic table. They have the same atomic number but different mass numbers, and that's because they have a different number of neutrons in the nucleus. In most cases, the average mass number is given for an element. This example here shows that there's 3 isotopes of hydrogen. Now it's just the first one that appears in the periodic table because that's the average that there's most of, but there is actually other versions of hydrogen. that have different number of neutrons, so different mass numbers. You will need to know how to calculate the average mass number, and that's based on the abundance or how much there is of it. Look at this example, chlorine. Chlorine's got two isotopes, so there's two versions of chlorine, chlorine 35 and chlorine 37. There's 75% of chlorine 35 and there's 25% of chlorine 37. So what's the relative atomic mass of chlorine? Well, you would take chlorine 35 and times it by 75, and then you would take chlorine 37 and times it by 25, and then you would divide that by the total amount, which is 100, and that gives you 35.5. So that is the relative atomic mass of chlorine that you would find in the periodic table. Here's a 6-mark question if you pause the tutorial and give yourself 10 minutes. So, describe the structure of sodium atom. So there's lots you can say here. First of all, you would need to look in the periodic table to get the atomic number and the mass number. Remember, you are given the periodic table in the exam, so use it. What do those numbers tell you? First of all, it tells you that it has 11 protons in the nucleus, and these are positive. It then has 11 negative electrons in the shells. We'll come back to how they're arranged in a minute. It has 12 neutrons in the nucleus, and that's figured out by taking 23 minus 11. Let's look at those electrons. The electrons are arranged as follows: 2 in the first shell, then 8, then 1. So 2, 8, 1. And look at the diagram there as well. I would suggest adding diagrams to questions like this because it shows extra knowledge and shows the examiner what you mean if you're struggling to describe it. So we've looked at the history of the atom, atomic structure and electronic structure.